We are live. We are live. Okay, so day 424. No, according to my watch, it's 424. Okay, so our objective today, what we want to talk about is arithmetic, sequences, and series. All right? Write that down. And then I'm going to put it in English for you, okay? Instead of math words, but in English, okay? So arithmetic means this. Arithmetic, the whole arithmetic means you're adding the same thing every time. It's like arithmetic's like adding, okay? So we're adding or subtracting same amount each term, okay? So if it's arithmetic, we're adding. And it could be subtracting, but it's the same thing each time. Does that make sense? So an example, where's our warm-up, okay? In our example, 5, 7, 9, 11, 13. That's arithmetic because we're adding 2 each time, aren't we? And then we're adding 2, lo and behold, the 2 winds up in the formula. We're going to see that today, how the 2 winds up in the formula, okay? Now, again, a sequence is just a list of numbers. So an arithmetic sequence is a list of numbers made by adding the same to each term. Okay? So, sequence is just going to be listing the numbers. A series is to add them all up. And we'll talk about that on the back side, okay? So we're just going to list them, okay? So we've got a formula. And in our formula, there's a few things we need to know, okay? First of all, A1, if you see A1, it's just your first term. That makes sense, right? We've seen that. A1 is our first term. It's our first term, okay? So, in this example, the one Rory did, our for A1 was 5, right? It's just our first term, okay? N is just the number of terms. So if I want to make the 10th term, I'd plug in 10, because that's my number of terms. If I want to make the 20th term, I'd plug in 20, because that would be the number of terms. Does that make sense? So I'd have A of 20, which would be, say, here's my 20th term. I plug in 20 to get my 20th term, okay? Now, D is the difference. D is the difference. Let's call it the, excuse me, Mrs. Hesse, forgive me, we're going to call it the adder. But you know what I mean by the adder. It's the number we're adding or subtracting each time. I know, poor English. I can't spell and I can't talk. That's the way. Okay, so it's the number. So it's just the difference between each term, but it would be the thing that we add each term to, okay? In this case, in this example, D would be 2. D is 2 because I'm adding 2 to each term. So in this case, D is 2. Okay? All right, so now, example 1, write a rule. So if we need a rule, whenever it says write a rule, we need a variable. Okay? You've got to have a variable. So whenever you make a rule or an equation, when they say rule, what we're going to do is make an equation or a formula. We're going to make a formula. And if we need a formula or an equation, we need a variable. Okay? For us, the variable is always going to be n. And the reason it's n is because then you could plug something into it, right? So n's got to be the variable. So if I want to make the 10th term, I know I'd plug 10 into n, right? If I want to make the 100th term, I'd plug 100 into n. So n's are a variable, okay? So it says it's arithmetic. So if it says it's arithmetic, we have a formula, don't we? Okay? So if it says arithmetic, we have a formula. So let me write that down. We're going to go A of n equals A1 plus n minus 1 times d, okay? So that's our general formula. Let's make it specific, okay, to this particular problem, okay? So let's see. I'm going to go 3, 8, 13, 18. So I'm going to go a of n because I need a formula. Keep n as a variable. It's going to equal a1. Well, I know a1 is 3, right? So plug the 3, that's my first term, into a1 plus, again, I'm trying to make a formula, so we're going to keep n as our variable, n minus 1. And I know what d is. D is the difference. Well, in this case, I'm going up by 5. D is 5, so I put 5 right there. Okay? Yes, Cole.
So we don't know that n is 20, because isn't that the number?
Right, right. You're totally right. You're ahead of me. Awesome. So there's two questions here. One is write a rule, which I'm doing right now, and then I'm going to go ahead and plug in 20 into my rule. Great question. So I'm going to do both parts. So, okay, so my rule, or my formula, let's see if I can simplify this. A of n equals 3 plus a 5n minus 5, right? I just distributed. And then I'm going to get a of n equals negative, I'll go 5n minus 2. You okay with my formula? Now, let's do a Cole suggestion. We've made a formula, general formula for this sequence. I mean, I could then make any term, because I've got my rule, right? Here's my rule. But let's do a Cole suggestion. Now let's make the 20. So I'm going to go, okay, a of n then, or a of 20 equals my 5 times 20 minus 2, which is 100, minus 2, which is 98. So my 20th term is 98. Pretty handy, because had we not known this formula, you would have had to have just kept plugging in and making it, plugging in, plugging in. You would have had to just list it until you get the 20th term, right? So a lot better to have a formula than just trying to make the whole thing. Thumbs up? This is not that hard, is it? Okay. Okay, example 2. Now example 2 is a little weird because we got A7 and we got A26. So it's still arithmetic. So if it's arithmetic, I'm going to write down my arithmetic sequence formula. A of n equals A1 plus n minus 1 times d. Okay, now I want a rule for this, but I don't know the first term, right? So I know A7. So what I'm going to do is I need A1. What we're going to do is take a look at it, and I'm going to go, just watch me do this for a second. Just watch me do this. So A7 is 17. Okay, that's my A7. What I want is A1. So I'm going to take and move myself all the way from 1 to 7, right? Now the pattern is going to be the same from 7 to 26 as it would be from 1 to whatever, right? The pattern's not going to change, right? From 1 to whatever is going to be the same thing from 7 to 26, right? So let's just hypothetically call this A1. Let's just call it A1, okay? So let's bump ourselves all the way forward into the sequence, okay? So let's call this one A1. So if I call 17 A1, then I had to go back 6, right? I'd have to go back 6, which would make A26. So A26 then, A26, which is 93. If I bump back 6, then, huh? Oh, thank you. Thank you, thank you. So if I bump A7 to A1, I went back 6. That would make A26, if I bump 6, to A20. Okay, now hopefully I'm making some sense on this, all right? So I took A7 and moved it all the way to A1. I'm moving the whole sequence, shifting the whole sequence, which is going to make A26 shift to A20. Because I went back 6 on this one, I went back 6 on this one, so I'm going to go back 6 on this. Okay, now if that's my question, let's take a look at our formula. So I have, in a sense, A20 equals A1. A1 now is 17. Plus n, well, that's 20 terms, n minus 1 times d. See, I don't know what d is. I don't know what d is. I want to find d. And I want to find the first term too, right? Okay, now, A20, I know what A20 is. It's 93. So, okay, 93 equals 17 plus, let's see, this is a 19d, right? And I can solve for d. Okay, so if I solve for d, that's easy. Minus 17, what's 93? Oh no, 93 minus 17. 76 equals 19D divided by 19, and D is 4. So the difference is 4, okay? So far so good. I've got D, I know what D is. D is 4, but I don't know what A1 is. I don't know what the first term is. So we got two choices. One to be the easiest way, and that's just to go backwards and find the first term. That's the easiest. Or I could use the formula, okay? The formula would work, but let's do it the easy way, okay? Okay, if I lost you, are you with me? Are you kind of okay? So let me just use the whiteboard, even though I'm recording. Let me use the whiteboard, okay? So, you ready? 1, 2, 3, 4, 5, 6, 7. Okay, let's go back to the original problem. Let's say the original problem says that 17 is here. 1, 2, 3, 4, 5, 6, 7, right? Can we get to here? How are we going to get to here? Yeah, minus 4. You guys agree? If D is 4, that means if whatever this was, I'd have to add 4. Add 4. Add 4. Add 4. Add 4 to get to 17, right? So let's just calculate, okay?
-7.
Did you guys already get it? 13, 9, I guess I don't need your calculator. What do I? 5, 1, and
-7.
so A1's -7, right? So if A1 is -7, worked it all the way back. So we worked all the way back to A1 is -7. We can make a formula. So here's my formula. You ready? A of n equals A1, which is -7, plus n minus 1 times 4. There's my formula. And I probably will simplify that. Right? I know my first term is because we worked it backwards, right? I need a variable to make a formula, n, and D is 4, so if I work this backwards, let's see, this is -7, plus a 4n minus 4, or a 4n minus 11 is a better formula, okay? Hopefully I did not confuse you on how I did this, okay? The trick to this one is realizing that my sequence isn't going to change from 1 to 26 versus from 1 to 20. It's the same exact sequence, we just have to shift where we start. Right? Should we turn the page? Okay, turn the page. All right. Now, arithmetic series. Okay, now what about a series? Okay, well now a series is just simply we're just going to add or we're going to get the sum of an arithmetic sequence. All right, we're going to get the sum of an arithmetic sequence. I'm going to go back to what Rory did on our warm-up. Thank you, Rory. I kind of volunteered to even though I wasn't quite your mother. So let's take a look at what Rory did, okay? So, in our warm-up, here's Rory went. She made them all 5, 7, 9, 11, 13, and that wasn't too hard, and she added them all up. But what if this was a 50? What if that was a 50? Wow, that'd be a pain, huh? Would it be nice if we had a formula? And you know what? Lo and behold, we have a formula. And there it is, okay? So we got this formula right here. S of n. S for sum. Does that make sense? S for sum. So S of n equals n, which is the number of terms, however many terms the case. So if we want to do Rory's, which we could do Rory's, 50, right? N would be 50. A1 would be the first term. So the first term in Rory's was 5. Plus A of n. Now A of n has to be the last term, or in this case, the 50th term. So if A of n is going to be the last term, so A of n is going to be the last term. Okay, now this is not that difficult. If I did do this, 1 to 50, then the last term would be plugging in 50. Does that make sense? Okay. Divided by 2. Okay, so example 3. Find the sum of the first 30 terms of 5 plus 8 plus 11 plus 14 plus 17. So let's take a look at our formula. Our formula is S of 30. S of 30. Okay, write that down. S of 30. Now the reason I wrote S of 30 is because we not need the sum of the first 30 terms. So n, number of terms, n will be 30, okay? Equals. parentheses, n. N is 30, right? That's in our formula. N is 30, number of terms 30. A1, I know A1 is 5 plus, AN. Plus AN, okay? Or A30. So what I'm missing, I need the first term, and I need the 30th term. I don't have the 30th term. So what do? Go home, take a nap? Sounds like a great idea.
Yeah.
Go outside, smell the flowers, sounds like great fun. But no, wait. We have a formula. We have a formula for finding the 30th term, right? We actually have a formula for finding the 30th term. Right? So let's take a look. This is a two-part problem. So, okay, I need the 30th term. So I need A of 30 equals, let's see, the form is A1. So I've got my A of n equals A1 plus n minus 1 times D. I'm going to use that formula, okay? So I need this, I need to make the 30th term. I'll do that real quick. A of 30.
Is that A to the 30 right there?
That's A to the 30.
Think you'll-
Yeah, and you know why it's A to the 30?
Because the first 30 terms right there.
Smart guy. Smart guy. So let's use our formula. I need to find A of 30 so I can plug it in here. I need the last term, right? So A of 30 is equal to A1. Well, that's 5 plus parentheses. N is the number of terms. Well, the number of terms is 30. I need 30 terms minus 1. And D is the difference, right? What's the difference between each term? 3, right? All right, I'm going to use my calculator because I trust my calculator. So I'm going to go 5 plus parentheses 30 minus 1, which of course is 29, times 3, and I get an answer of 92. So I know what the last term is. It's 92. So what I'm going to do, I'm just simply going to take this 92 and put it right there, okay? Because that's my 30th term. So finally, ready? S of 30 equals 30 times 5 plus 92 divided by 2. And again, I'm just going to use my calculator because that makes it easy for me. Ooh, you're way ahead of me. I like that. 30 parentheses 5 plus 92 divided by 2. I get an answer of 1,455. That's what I got. Yeah, so S of 30 is 1,455. Okay, now, so what do we just do? Because I like to put things into perspective so you get it, okay? What do we do? Well, we could have just kept adding 3. We could have made all 30 terms, right? Right? And then use our calculator, plus. What a pain. And that's what we did, but we did it with 2 formulas, which I think is a lot faster than making them all and then going plus. Okay, thumbs up, 1 thumb up, 2 thumbs up, sideways, where you at? Okay, all right, now, last but not least, example 4. This is a question. It's a question. It says, in mathematical words, it says, find the sum. Find the sum from 1 to 27. So it means plug in 1, get an answer. Plug in 2, plug in 3, plug in 4, plug in 5, plug in blah, 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 plug in 27. Then take all of those 27 numbers and add them up. Wow. Now, first of all, this one is arithmetic. It really is arithmetic. But how do you know it's arithmetic? We could hypothetically make some terms. So if I plugged in 1, just if you don't know it's arithmetic, it is. If you plug in 1, you'd get 9. If you plug in 2, you'd get 11. 12. If you plug in 3, you get 15. So you're always going up by 3. If you want to make a few terms, you're going up by 3 each time. Does that make sense? So it's arithmetic. Oh, I like that because I have a formula. I have a formula. Here it is. If I'm going to add up an arithmetic series, I'm going to use my formula. So I'm going to go, okay, so my formula is S of n equals n times A1 plus AN divided by 2. That's my formula, but this one's actually easier than the one we did before because we have a formula. So S of 27, because there's 27 terms. right? There's 27 terms. Plug in 1, plug in 2, plug in 3. So let's go S of 27 equals N, which is 27. A1's my first term. Now, I need to make my first term, but that should be easy to make. Plug it in. So my first term, A of 1, is simply going to be 3 times 1 plus 6, right? That's my first term. And that's going to be 9. So A1 is 9, so I'm going to plug that right there. Plus A of N, or A of 27. Well, that's easy to make. So I'm going to make A of 27, but by just plugging it in. I can plug it in, plug 27 into the formula, we'll get the 27th term, okay? Equals 3 times 27 plus 6, right? So it's 3 times 27 plus 6. I get 87. So plug that there, 87 divided by 2, and I'm just going to use my calculator. Clear, clear, clear. 27 times parentheses 9 plus 87 divided by 2, and I get an answer of 1,296. Okay. Now, let me go ahead and summarize, because it's worth summarizing.